Yo, what's good with it? It's your boy Street Coder Nate. We back at it with another Python lesson, interview prep with Python. I'm about to just pick right up from where we left off at the last time. So I'm gonna just share my screen and then we're gonna get to it. So let's get to it. Let's see. Share the screen real quick. All right, so let me pull up that algorithm, which is right here. All right, bet. So the last time we tapped in with Leak Code, I was putting y'all on Leak Code, and I was teaching y'all, like, I was telling y'all we about to go through, what are we going through? Let me go back real quick. We're going through algorithms one, which is the easy and medium ones, and then we're gonna build up a structure of how we're gonna do this, like take interviews, and then once we get through all of these and understand the easy ones, then we're gonna tap into the hard ones. So each time y'all come here, it would be like a lesson. We'll learn like merge sort, some type of algorithm or data structure, and then we'll tap into an algorithm that's like based upon that algorithm or data structure. You feel me? So today we're just gonna pick right back up from where we left off last time, which was the binary search question. The binary search question, I'm gonna restate it for y'all so y'all can remember. This crayon grape hit different. All right. So this binary search, and I'm over here on my iPad. Let me get over here. All right, there we go. All right, so the binary search, it says, given an array of integers, numbers, so this array is called nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. All right, and I told y'all we're gonna skip this part first and give the inefficient algorithm. So after the interviewer has read the question, you say, "Thank you, interviewer. I appreciate you for reading this question." The interviewer then typically goes in and starts reading the examples and showing you, like, basically giving you an example as to what the question actually means. So if you look at it, we got input and we got, so example one is they got the input. They said the input is going to be called nums and it's going to be an array. So an array is just a list of numbers and they separated by commas, and they it's an array because it starts with a left like square bracket and a right square bracket. And so the numbers in between the list is -1, 0, 3, 5, 9, and 12, and our target is 9. So they said the output after running this function, you will be getting 4. So basically, the explanation, give you an explanation too. 9 exists in nums and its index is 4. So if we start counting the index 0, 1, 2, 3, 4, 9 is at index 4. So that's an example of like this problem right here. Given nums and the target, can your function print out the right index as to where this target is? So you got the explanation 9 exists in nums and this index is 4. That makes sense. All right, let's see example 2. Nums is these numbers and the target is 2. They can't find the target 2 up in here, so it says 2, or the output is -1. Let's figure out why. They got the explanation. The explanation says 2 does not exist in nums, so we return -1. My glasses is foggy. So we return -1. So if we can't find the value inside of the list, then we return a -1. I bet. So now what we're tasked with is figuring out how to create an algorithm that will do what these examples just showed us what we need to do. So That's what this is all about. So we about to tap in. I told y'all, first thing y'all do is ask for another example or for them to re-explain the question. This gives you a little bit of time to break down this question. And so I'm gonna tell y'all what I be doing when I'm breaking down this question. So what I'm gonna do is I always do this thing called givens. So let me actually share my iPad screen real quick. We got a quick time player. Yeah. I do it the old school way. Don't judge me. But cause fucking motherfucking airtime not working. That shit don't be working for some reason. I figured this shit out. It's probably because I need to update some shit, most likely. All right, here we go. So I got my iPad up on this hoe. And so what we about to do is we about to break down, we pretty much about to dissect this question. And the reason we need to dissect it is so that we can figure out the most important parts of this question. And honestly, real talk, I'm gonna be real, like I could do math all day, any day. But then like in college, when they started adding like the word problems around the math, they give us like these thick ass like paragraphs and it'd be a whole bunch of math in between too. And you had to figure out how to like solve the equation, but it was just so many damn distractions in that paragraph. I'd be up in that bitch like I'm confused, like how y'all expect me to go through all this shit? And it's like paragraphs. I never read that much in math. And so the reason I bring that up is that because that reminds me of what's going on here is like these are algorithms, kind of like math in a way, but they stuck inside of like word problems. So you got to understand the word problem, which I didn't understand when I was doing these math problems. I was just trying to get to the math, but that's what most people try to do here. They try to get straight to the code. And you don't want to go straight to the code. First, you want to understand it as a word problem. That's what I should have did in math. I should have understood it as a word problem. So what we need to do is say, this is a word problem. What are the most important things in this problem? So here we go. Given an array of integers, nums, which is sorted in an ascending order. That first comma right there is, we know we got an array, or we know we got a variable called nums, and it is an array in ascending order. Bet. That's our first given. Hold on, let me write this. Call it givens. Oh, that's too big. Givens, like that. Okay, so these are the givens in the problem set. Givens. All right, nums. We are given nums. Bet. And it's in ascending order. It's a list in ascending order. Cool. So then, and an integer named target. So we also got target. We also got target, and we know that this is just an integer. All right, bet. So now write a function to search target and nums. So basically they saying search this value. You got this value. It can be anything, 9, 10, 11, 12, 13, whatever they want to make it. We want to search this value inside of this list of numbers right here. We want to search this value inside of this list of numbers. So what they say is, if target exists, then return is index. So here's another given. Look for target inside of the list named nums. Bet. And then I put a period over, so I could say if it exists, then I need to return the index of the number. And if it don't exist, I just return -1. All right, for sure. This is what I'm doing as the interviewer is re-saying the question right here and giving me another example. I'm really breaking it down. So now I'm like, all right, bet I got a better understanding as to what I'm doing. This part, right? Remember, this part right here, this is the most important part right here, is I'm looking for a target inside of the list of nums. So I know I got a list of nums and it's sorted in ascending order. And then I got this target. It's just a random number. I got a list of numbers and I got one number. I'm looking for that number inside of the list, right? So if that number exists, I need to figure out what position in the list does that number exist at, and then just give it back to the person who asks, does this number exist, right? And then if it don't exist, I say -1, my dog, that bitch not in here. So that's all we doing in this algorithm is asking, does this number target right here, does it exist in this list? That's all we doing. Bet. So now that we know our givens and we know a basic idea of what we're doing, now we got to come up with a brute force algorithm to solve is target in the list. And so once again, don't jump right to the code. Please do not jump right to the code. Think about this logically as a human being. How would you search through a list and look for a number or look for anything? Say you had a list of names and you had to find a specific name in that list. What would you do? You would go to the top of the list, compare each name. Is that the name? Nope. Is that the name? Nope, nope, nope. Until you found it. Then you'd be like, it's at number 3, or is that number 6 or number 20 in the list, wherever one it is. What I just explained is the same idea as to what this is asking us to do right now. So taking that idea, what you say is, well, once again, we will take that name and we will look at the first item in the list, compare it. If it's that name, then cool. It's the name. We ain't got to look no more. Let's figure out which position in this list it is. It's the first name. It's the first position. This name was the first name in the position. Cool. That's searched through the list. But what if it's not the first name? What if it's like the 20th name? So then you got to go, is this the first name? Nope. Is this the second name? Nope. Is it the third name? Nope. Is it the fourth name? Nope. Is it the fifth name? Nope. And you so on and so forth until you get to the 20th name. So, and then you say it's the 20th name. I found it. Here's the name and here's the position. It's number 20, right? But let's say that I asked you to find a name that's not in there. So you search, let's say the list has 10 names in it. You search that whole list of 10 names. Well, how do you know that that name ain't in there? Well, you know, because you went through all of the names, you got to the end of the list, and you haven't found a comparison in the list that's the same as the name that you was looking for. Therefore, all right, you gonna say that name not in the list. Cool. All right, bet. So we got this idea down in English, right? That's the idea in English. Search through the list, comparing one by one by one. Now, that's the algorithm that we could do here. And that's, you know what? That's what we're going to do. We're going to write that algorithm out. And I'm just going to let you know it's an inefficient algorithm. But just for this is what, the second video, we're going to be doing hundreds of these, or maybe not. We're going to be doing tens of these videos of getting y'all ready. So I'll show y'all the inefficient right and the inefficient, which is the linear, which I just described, checking each one until you find it. That is a linear operation, and we're gonna get into that right now. So how can I translate check each name? Well, first, we're not doing names, we're doing numbers. So okay, check each number. And it's not a list, it's an array. So check each number in the array and compare it to the target. Okay, if the number is the target, return the index as to where that number is at in the array. And if it ain't the target, move on to the next one and then check the next one. And if we get to the end of the list, just return -1. So we need to write that in Python. And so before I really start writing the code, I really write the code with a pencil. I write it out in pencil. I think it's because of college. Like I took a lot of tests and we had to write code on paper. Like when we took tests, we had to write that shit out on paper. And ever since then, I don't know. Every time I need to do something serious with code, I always write it out on paper and then I code it up real quick. Like I write out a rough draft on paper and then I code it. But it helps me really organize my ideas. But I think it's a great idea. So let's think about this real quick. So let's take this idea from right here and let's take that example and write it over here on a piece of paper. Okay, so we got we have an array called nums, and it has -1, 0, 3, 5, 9, 12. And then we have another variable called target, and target is 9. Now, we want to find 9 inside of nums. We want to find the target inside of the nums. So just like we would do with the name, we would take whatever the name is, but here we're working with a number, so 9. We're going to take the name and we're going to check it against every one of these in here until we find it. Is this 9? Nope. Is this 9? Nope. Is this 9? Nope. Is this 9? Nope. Is this 9? Hell yeah. I bet. You're 9. Which index do you live at? All right, so now we need to know the index. How do we count the index? Starting at 0, 0, 1, 2, 3, 4, 5. So index 4 is where 9 lives. So we will return 4. And if you look at the output right here, it's 4. So bet. We know how to do, we just did this in English. We wrote it out, we saw the example, we drew it real quick. So now we just need to translate this little process that I did right here into code. And the code that we're gonna use is Python. So let's get down and dirty with it. So I ain't finna teach y'all Python. I'm gonna assume you already know Python. This is interview prep with Python. So come with the Python knowledge. I'm sorry if you don't know Python, just follow along. You should be able to get the understanding. Plus Python is pretty readable. You'll be able to, Python real quick to learn. This is why I'm doing this stuff in Python. So if you still new to coding and whatnot, and you need a back-end real coding language, go Python. It's real close to C++, but it take a lot of the bullshit away from C++ and it just goes stupid. So I'll use Python for real. Tap in with it. So, all right. So first things first is, when we about to write the code, we need to write it the correct way. And so right here, they got a C++, but let's change it to Python. And with Python, all they got is they make it a class, but I ain't about to make it a class and whatnot. And they got def, they call the function search. They pass in self because it's a class, and then they pass in nums and target. Remember, nums is the list and target is the number that we're looking for. And they tell you that type of nums is a list, the type of target is an int, and then a return type, meaning that when this function finishes, it expects some type of value returned back. And that means, so this is right here, the return type is going to be an integer. So that value that's returned back should be a number, is what this says. But we don't got to write all this out. How I'm about to write it, you can simply, I don't really be messing with classes for real. You can simply just go like this. Bang that hole back here. Let's see, can I bang it? Yep. Bang that one right there. Let's see, just highlight these. Bang that back there. Cool. And then because we ain't got this in the class no more, we can take that out. All right, cool. So this is the basic function that we're gonna create. And I want to call it okay, you would call it search. Actually, I like to make my functions pretty specific, so I'll call it search _ for target, like that. Search for target. And so but like I said, first I write mine on the iPad. So I'm gonna go over to the iPad and say, all right, def, and my function name is search for target, and it passes in nums, and it passes in target, like these. Sure. Bet. All right, so now that we got search for target, this is our function. Now that we got that on here, what do we need to do? Well, we need to translate this process right here. This is just a simple process of taking a number and comparing it to every number in the list. Well, how do we know how to iterate over a list? We use a for loop. So all we got to simply do is use a for loop and compare the number to the current number in the list. So let's just do that. This is pretty simple, right? So let's hit the for loop. I'm gonna write the code. I write the code in blue. Yeah, let me change it over here. Yep. All right, bet. So def search for target. So we'll say for num and nums, and then we'll go if num equal target. Found a dilemma. We need to return the index, but we don't have an index just yet. So let's figure out how we can get the index. We can get the index by saying for num in range, RANG, in range length of nums. This gives us 0 through num minus 1. Actually, minus 1. Then we go nums. So we will call this index. For index and range, so using that range base, we get the index now. So for index, we go nums index. Cool. Nums index equals target. So what is nums index? Well, nums is this array right here. And then if we use this square bracket on nums, so if I put like 1, this will go to the index 1 and give me this value 0. So I say basically I'm going to index increments from 0 to num minus 1, the length of num minus 1, which is just 6 here. Actually, I'm tripping. Yeah. Which you go, from 0 to length minus 1, which is 5. So then it end with right there. Cool. So we check in nums and we check it against target. And do they equal each other? If they do, return the index. If not, we just go right back up to the for loop. And if this for loop ends and we didn't return the index just yet, then the only thing we need to do is return -1. Okay. Honestly, this function works. We can write this function out and let's do that. But once again, this is the brute force. This is the one that the one that works, but it's inefficient. So let's write this out real quick. We got for index in range length of nums minus 1. You see how easy this is once I already just write it out. If nums at index is equal to the target, and we're going to return index. And then if we have to get through that whole bitch, then we're going to return -1. Like these. I should have the music in the background. All right, let's test it. So basically, now that we wrote the code right here in LeetCode, what we can do is, let me increase the whole screen. Now that we wrote the code in LeetCode, now what we can do is run some test cases. So let's see, run code right here, run example test case. So we run the example test case. Let's see. Error, global name solution is not defined. Oh yeah. All right. So yeah, they want a class name solution, class solution, like these. I guess the autocomplete, however they set it up, you just gotta set it up that way. You do it like that. All right, class solution, and then we're gonna pass in that. There we go. Indent this over like that, and bang. Okay, and they probably just want this called search too. It's not like this in the coding interview. You can name it whatever you want to name it. Just leak code type shit. All right, we got the wrong answer. Let's see, we got the wrong. Why we got the wrong answer? Let's see. We should not have gotten the wrong answer. All right, so your input, and then my output was -1, and they expected 4. So let's figure out why. Ooh, look, the reason why was that this -1 was indented inside of this for loop. You need to pull that whole back like that. Let's rerun it. Come on. Bitch. Let's get it. You see, the answer, I got the answer right. It got accepted, right? You would think like, all right, got the answer right. Like, give me the job, dog, right? But the thing is, like, look, if I submit it though, once I submit it, let's see what happens. Sit back up. Look. Expected 0 and got -1. Okay, so that's tripping because that should have worked. Let's see. So for index, if nums index equal target, return index. Oh, why in the hell? Oh, you know what? Because I ain't do from 0 to length -1 like that. Okay, let's see. Now let's submit it. Y'all tripping. Y'all tripping. Okay, so this is dope because now what we can do is go to the test case and we can update the test case. This is great. We can update the test case to say we want to pass in 5 like that, -5. And let's run this test case now. And let's see why this isn't working. Wrong answer. Yep, we got -1. The answer should have been 0. So let's see. For index in range 0 to length minus nums -1. Oh, wait. Oh, yeah, because it's exclusive. I forgot. Bet. So now we can run it in. Yep, there we go. So let's now submit it, and we should pass that one test case, but we should still get the wrong answer because what I'm looking for. Okay, we got it. We should not have got success. That's tripping. All right, so we gotta accept the answer. We got the answer to succeed, but the thing is, the reason why we shouldn't have got it to succeed is because we missed out on this part right here where it says you must write an algorithm with O log n runtime complexity, right? And so we didn't take that into consideration when we created this algorithm right here on the right hand side. See, this algorithm, excuse me. God damn. All right, see, this algorithm right here, what it does is it iterates through the entire length of nums. And so the length of nums is what this n value is, right? And so the n, if nums, so the length of n or the length of nums is, let's say, n, the letter n. Let me get my iPad out so we ain't got to think too abstractly. Okay, so the letter n is going to be the length of nums, right? And so let's say that nums is an array, like in our example up here, nums was an array, and it had a length of 1 or it had a length of 6. But nums can be another array, like we tried out in our example where the length was only 1, and it can the runtime could be shorter because checking one thing is going to be shorter than checking like 6 things. But we like to think about as these things go to infinity. So let's say that let's say the list was an infinite list. It would take infinite amount of time to run this algorithm the way we ran it. What this problem is saying is we want to take infinity and log it. Now, the log of infinity is less than infinity. You get it? Because like the log of something is less than itself. Therefore, they're saying we want this function to run faster than this linear time complexity where you check everything. We want you to be able to run it in a time complexity where it's like half of that time. And so we didn't take that into consideration when we was looking or when we wrote our problem out. Let's see. When we wrote the problem out, where's that bitch at? I might have to open this bitch up wider. There we go. Yep. So we didn't take that into consideration when we wrote the code out. So what I'm about to do is get y'all right, because I'm not about to just teach y'all some code or teach y'all just an inefficient algorithm and then just because it got accepted. We want to make sure that you get the job. And so we want to make sure that we hit all keys in the problem statement. And the big key here is that they want this to run an O log in time complexity. This is very important. If you're not hitting the time complexity, they don't want you. All of these companies have all this big data. They doing all these algorithms. They want you to be able to write an efficient algorithm if it comes down to it. 9 times out of 10, you probably won't be doing that in the first couple of years. But as you get into it, they want to make sure that they know that they can trust you to write efficient algorithms. All right. So with that being said, let's make this algorithm more efficient. So the way that we can make this more efficient, let's take a look at, let's go back to the iPad and check out the iPad. So let's do this example. Let's look at this example over again. So we got nums and, bro, my iPad tripping today. Nums, and that equals -1, 0, like 5, or like 3, 5, 9, 12. 3, 5, 9, and 12. All right, bet. And then we had our target of 9. So one of the things, when you making your algorithm more efficient, one thing that you need to do is go back over the problem statement and make sure that you're using everything from the problem statement. Because if you're missing out on things from the problem statement, then you most likely are missing out on the efficiency. Like that's the part that you can use to make it more efficient. So let's go back and check out the problem statement real quick. And it says, given an array of integer numbers, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise -1. Right. So did we consider all of the information in our algorithm? Well, let's try it out. Get an array of integer nums. So we have an array of nums, clearly right here. I don't know why we're doing this or doing that. Give an array of nums like that, cool. So we clearly take that in consideration because we check the whole list of nums right here, which is sorted in ascending order. Do we take into consideration the sortment of the numbers? We don't really take that into consideration inside of this. Like regardless if the numbers are like in ascending order, if they mixed up, whatnot, we're going to search this algorithm searches the whole thing to find the number. But if we could use the fact that these numbers are sorted in like increasing number or increasing order, that could possibly be the bridge to our optimization. So let's take that into consideration as we look at these numbers. Let's go back over to the iPad real quick. Let's take that into consideration real quick. So we got these numbers going in order. And we saying, is there a way that we can find target without having to look at all the numbers? And so I'm gonna just take a lucky guess and say, like, let's actually not even a lucky guess. Let's think about this logically. We got all these numbers going up. They starting from, in this example, -1, and they go to 12. They're increasing, and you got a target, and that target is 9. Now, think about this as a human. You got -1, and then you got 12, and then you got this target 9. Would it make sense for you to look at the beginning of the numbers, knowing that you got number 9? Wouldn't you think, oh, number 9 probably closer to the end? So why even spend time looking at the first few numbers, right? I can just kind of like skip through those numbers and then look at when it gets real close to number 9, and I can really start looking at those numbers. I can pretty much skip that. That's what we're getting at here. But we need a more methodological, however you pronounce that shit. We need a method to do this for the computer, because we just can't say skim a little bit. We can say that, but we gotta say it in computer terms. So skim a little bit. Well, computers understand math. Skim a little bit it means something in math. What does that mean in math? I'm gonna give you an idea what this means in math. We don't know how much to skim. See, humans, we can use our eyes and we can check real quick which ones to skim, but we don't really know how to say that to the computer. But what we can say is, computer, check, like, go to half. Shit. What we can say is, like, computer, go to half the list and check the value. My bad. And check the value that's at the middle point in the list, right? So now we just split the list in half. We got this side right here, and then we got this side over here. Bruh. And we got this side over there, and this side over here. And we literally just split this list. We just split it in half. How did we just split this list in half? Well, we know, everything on the left side of the midpoint is going to be less than whatever the midpoint is, right? So right here is 5. The midpoint is 5. Everything on to the left of 5 is less than 5. And everything to the right of 5 is greater than 5. This is thinking about this logically, right? Because everything's increasing. Every number is increasing. Therefore, if we cut it in half, everything to the left of the half point is less than it, and everything to the right of the half point is greater than it. So that makes sense. Cool. So now what we can do is check the number. Check the number at the midpoint. Is this number the target? Is it the target? Well, no, it's not the target, it's 5. Okay, cool. So let's do it again. Let's let's cut the so now we know first before I jump logical steps. So now that we just checked and we said, does 5 equal 9? And we know that it don't equal 9. My bad. Does 5 equal 9? Hell no. Okay, so we know that 5 does not equal 9. We already split the array in half. What does this mean about splitting the array in half? Well, now that we know that 5 does not equal 9, now what we can do is compare the number to see is 5 greater than 9, is 5 less than 9. So if 5 is greater than 9, then we know that if we look to the right of 5, then everything is going to be greater than 9 because 5 is greater than 9 in that case. But if 5 is less than 9, then we know that if we look to everything to the left of 5, it's going to be less than 5 and still less than 9 because 5 is greater than 9. So what I'm getting at here is if the target is, let's say, greater than the value right here. So if the target is greater than the current value or the current number, if it's greater than the current number, so in this case, if 9 is greater than 5, what we gonna do is we gonna shrink the array down to these because there's no use in looking over here because we know that all of these are going to be less than 9. So there's no point in looking over there because they are less than 9. And so now what we need to do is just look to everything to the right of 5 because we know 5 is a 9 and 5 is less than 9. So therefore, we just need to look to everything towards the right of 9 or right of 5, which is only 2 numbers. Now, Pete, we just cut off 3 whole numbers with only looking at 1 number. We got to chop off, actually, we chopped off 4 numbers. We chopped off 4 whole numbers, and we only had to look at 1 number. That's a way more efficient algorithm than looking at every number. But we still didn't get to the main, we still didn't get the number yet. So we still didn't get 9 yet in our algorithm. So what do we do after we don't shrink it down right here? So now that we got it down to these two, we do the same thing. We cut it in half, right? And then we say, or we cut it in half, and then we say let's just say this is the target, or is the current number. So this is the current number, which is 12. And we say, first we say, does target equal current number? Does target equal the current number? Question mark. If it equals the current number, return the position. But does 12 equal, which is the current number, does that equal the target, which is 9? It doesn't. So now we need to go do the other checks. Well, is the target greater than the current number? Let's ask that question. Is the target greater than the current number? Well, the target is 9 and the current number is 12. So it's not greater than the current number. So then we have to say, is the target less than the number? So if it's less than the current number, what we need to do is look to the left. So look to the left and cut it in half. And so cut the array in half like that to get the midpoint. And that'll just make this 0. So then this would be the only thing left up in there. and then we'll check the target and go. So if it's not, then we look to the right. Look to right. Cool. So this is really our algorithm, is check the target, or first we gotta say, we say target is the midpoint. So target, or no, not target. So first we gotta find a midpoint in the array. So we gotta find a midpoint. And what would the midpoint be? The midpoint, let's just say, is the middle of the array. So just taking the size of the array, take the size of num. Bro, this is fucking me up. We take length, and then we just divide it by 2, and that will give us the middle. So that's the midpoint. And all we doing is checking target each time. So let's target the current number, and the current number, what is current number? Current number is nums at midpoint. So look at us, we're updating this to code already. Current number, nums at midpoint. And then current number here is nums at midpoint. So let's start rewriting this so it look cleaner. So let's say we're gonna call this one, and this is called a binary search. So we'll call it binary search. Bro, I don't know why I keep sliding like that. I'm gonna close it out real quick. All right, and call this binary search. You're still doing that bullshit. All right, let me see. Like ghost touches. All right, you're gonna call this binary search. It takes in nums, and it also takes in the target. It's still doing that shit. Let's see. It takes in nums and it takes in the target. Let me just try to, I guess, do it from here. So remember, nums looks like this: -1, 0, 3, 5, 9, and 12. And then we're gonna say our target is equal to 9. This is nums. Cool. So we need to find our midpoint, right? So, because that's the first thing we need to do, find the midpoint. So we need, or I guess we kind of do need to find the midpoint, but more importantly, we need to first say we need a beginning point and we need an ending point, because what we're doing here is we're saying look to the left and look to the right. And the computer needs to understand what that means. And what that is a mathematical operation, pretty much. And so I'm already going ahead and say you need to know about where the end position is, and you need to know where the beginning position is, so that you can figure out where the midpoint is, right? That just makes sense. You can't know where the middle is if you don't know where the beginning and end is. So that was just logic again. Once again, this is all logic. You sitting there thinking logically the whole time. Okay, beginning, I got an end. How would I get the middle? Well, if I do end minus the beginning, what does that give me? The end minus the beginning gives me the actual length of this distance, right? End minus the beginning gives me the length of the distance. And then if I want to find the middle point of the length of the distance, I just divide it by 2, because then that gives me half. That gives me the middle point. But the thing is, the middle point is going to be moving all over the place. And so it's going to be displaced by the beginning each time. So we need to say plus the beginning at the end, or plus the beginning like that. And that gives us our current middle. So if we look at the numbers here, we got end. We need to figure out what the end is. End is going to be the length of nums minus 1. My bad, not minus 1. The length of nums. Should I do minus 1? We'll figure that one out. And then we got begin, which is just 0, because it's at index 0, and this is at index 6. So what we're going to do is iterate, and we're going to move begin, and we're going to move end in whenever we shrink this down. So basically the midpoint here is, I'm going to skip the while loop or the condition for the while loop right now, and I'm going to just go to finding the midpoint, and we go back to the condition for the while loop. And so the midpoint right now is, remember, end, and length is 6, and this is 0. So this is basically what we're doing. And this is the equation for it. So we got end minus the begin. We put that in parentheses like that. And then we divide that by 2. Put that in parentheses. And then we add the beginning. And that gives us our midpoint. So each time we got to do this calculation to get our midpoint. So once we got our midpoint, go back up to this equation, we just check the target against the current number. What is the current number? The current number is nums at midpoint. So cool, we could just follow this. If target equal current number, return a position. If target is less than the current number, look to the right. We'll figure what that out mean. And then if target is less than the current number, look to the left, and we'll figure that one out. So let's figure out this if statement. So it's simply literally an if statement. So if, and then you say target equal. If the target equals, what we doing, nums is the array. And if it's at the midpoint, whatever that value is, then we're going to return midpoint. Like that. Else if target is less than nums at midpoint. If it's less than, okay, so this is good. Here we go. We did greater than first, so we're just gonna skip down to less than. That's the one where we are. So if target is less than the current number, we're gonna look to the left. So what does that mean? So we come here, and let's say, get the fuck out of here. Why y'all keep doing that with my pencil? Okay, so if target is less than, let me circle this right here. So this is the array, those numbers. That's the array. And let's see, what is the midpoint? Let's run this calculation. So end is 6, beginning is 0. We divide this by 2. So that gives us 3. Then we add 0. So this gives us position 3. All right. And remember, we start counting indexes by 0. So 0, 1, 2, 3, 4, 5. And so our first index is 3. So we're going to go to index 3, and that gives us the number 5 first. So 5. So our first midpoint is 3. Oops. Our first midpoint is 3 right here. And that 5 is position, or 5 is the value at nums midpoint right now. And so now we run this algorithm which says is the current number 5 less than 9? Or less than, or is target less than nums? And let's just say the target is, for now, because right now it's 9, but it's actually not. So that we can figure out this part to right. So if the target less than the midpoint, well, yes, it's 4. So what we need to do is, what did we say before? We said if it's less than, we need to look to the left. This makes sense because everything to the right is going to be greater than. So we wouldn't want to look at anything to the right of 5 because they're all greater than 4, right? If the target is 4. So we want to look to the left because everything to the left of 5 is less than 5. So therefore 4 may fall off into that area. So we need to look to the left. Well, how do we tell the computer to look to the left inside of here? This is where the beginning and end comes, because now we need to update their positions. So we're going to move end. So if the number is, if target is less than the current number, so target is 4 and the current number 5, if target is less than that, what we're going to do is update end. We're going to move end to be, we're going to move end right here. And so what does that mean? End is midpoint minus 1. Because midpoint right now is 3, but we want end to be at 2 now. Because then we make this, because once we move into there, you got beginning starts right there and end starts right there, right? We just cut it in half. So we didn't even have to look at the other half. This is just by moving different numbers. So we're going to update end to be midpoint minus 1. So we'll say, if it's less than, we'll do end equals midpoint minus 1. And then we got L with target is greater than nums at midpoint. Well, if this happens, let's see what we need to do. So let's move this back up to 9. All right, so I'm gonna go orange with this one. So let's say now our current number is 5 again, and we're looking at 5, and we saying is the target, which is 9, greater than 5, and it is. So what do we need to do? Well, in the opposite case, we move the end point. So in this case, we're gonna move the beginning point. So what we're gonna do is move it to this position. We're gonna move it to this position. Where in that position is 4. We'll move it to that position. So 4, if midpoint right now is 3, well, 4 is just 3 plus 1. So the way that we move begin is begin equals midpoint plus 1, like that. So begin equals midpoint plus 1. All right, cool. So we kind of got the algorithm written out, but we missing this case right here with the while loop. So we got to figure out that case with the while loop. But we can kind of figure that case out right now. So let's clean up this part. Let's rewrite this part up here. So we got something clean to look at. All right, so nums is this array that goes -1, 0, 3, 5, 9, and 12. And then we got target, which is 9. All right, so this is the case where we need to run through our algorithm and make sure that it makes sense. So that's what we're about to do. So we say our end is length of nums, which is 6. And then we say our begin is 0. This is the initial things of the function that we do. Remember, the function start right here. Oh, fuck. The function starts right here. So first thing we do, we get the endpoint. Second thing we do, we get the beginning point. The third thing we do is we set the condition for the while loop. We'll come back to that in a second. All right. And the first thing we do inside the while loop is find the midpoint. And so we figured out the first time that the midpoint is 3. So then we got the target. Remember, the target is 9. So it's 9 equal to nums at 3. Nums at 0, 1, 2, 3 is 5. So does 5 equal 9? No, it don't. So we're gonna skip that case and we're gonna come down to this elif. It's the target, which is 9, less than nums at midpoint, which is 5. Well, no, so we're gonna skip that part and we're gonna come down to this one. Is the target greater than? Is the target greater than nums at midpoint? Nums at midpoint is 5 and the target is 9. So yes. So what we need to do is say beginning. Remember that was the midpoint. And then the beginning was here. And the end was here. We need to say beginning equals midpoint plus 1. So midpoint was 3. We need to make the beginning go to 4 right here. So now beginning is here at 4, and then the end is right there still at 6, like these. So now we, so now we go, now that we just updated beginning, we go back up to the while loop. We ain't hit the condition yet, so we gonna update the midpoint. So now that we got a new begin and an end, this number ain't gonna just be 3 no more. We get, so end is 6 again, and then the beginning is 4, and we divide that by 2. So that gives us 2. And then we gotta add the begin, and the begin is 4. So that gives us 6. So I knew it. We need to say end is length minus 1. That's why you got to walk it out, or else shit gonna be fucked up. All right, so let's see. That gives me 5. That fucks up that equation down to 2, right? Yep. So the first number would be 2 here. So we wouldn't even be checking 5. We would actually be checking 3. And yeah, okay. It would be the same thing because 3 is less than. So then we'll update beginning to be that one, and we'll be looking at these. Cool. So then beginning would be 3, and or end would still be 5. Begin would be 3. Divide that by 2. You get 1. All right. And then we add the beginning again. So 1 plus, what's the beginning now? 3. And that gives you 4. So then what they're trying to say, the midpoint would be 5. That wouldn't even make sense. Because the beginning is 3 now. 5 over. Yeah, I don't. Let's see. Because you got. Yep. So now, my bad. I got to run this math out. All right. So let's see. 5 minus 3. 0, 1, 2. 5 minus 3 is 2. Over 2 is 1. And then the beginning point is 3. So that's 4. So you're trying to tell me the midpoint between 3, 4. Yes, it is 4, Negro. All right. Yes. And 4 is the, yeah, I'm tripping. All right, my bad. I had to just check my logic. It actually works. So yep. So this updates to 4. The midpoint then updates to 4. We check 4 at 9, which is 9. So then we update the midpoint. I know I just jumped, but all you got to do is just slow down, go back around, and you'll see the logic that I did. it's all there. All I did was pause to make sure that the math made sense. But yeah, so now what we need to do is realize what's happening. We're moving the beginning number, we're moving the beginning to the right and we're moving the end to the left. So our while condition should say while the begin is less than or equal to the end. Because if the begin gets past the end, then we done with we don't check the whole thing pretty much. As long as the begin doesn't pass the end, we can figure out how far apart they are. Once they pass each other, it don't, we can't figure out how apart they are. We figure out how far past each other they are, not how much they getting closer type shit. All right, this is our algorithm. Literally right here is our algorithm. Look like chickens, but we're gonna run it over here up in the Python, Johns, and we're gonna get it cooking. All right. So first thing we do is we say end equals length of nums minus 1. Then we got begin is 0. Then we say while begin is less than or equal to end. Midpoint is equal to end minus begin. Divide that by 2. And then we're going to add the beginning on there. And now we check our if conditions. And you know what? I always like to, even if I'm doing coding interviews, I always put comments. So find the midpoint so we can divide the array. Let me just say this and have this minus all the time. All right, cool. And then I'll still say, like, interviewers like when you do comments. So the end position of the list. And then we'll just go the beginning position list. Like all right, cool. And now what we want to do is check if the target is equal to the current number. So we can just create a quick variable called current number, and current number will be nums. So we can keep making this readable. Interviewers like this as well. Nums at midpoint. Yep. All right, so that's the current number. So now I can literally say if the target is equal to the current number, then return midpoint. You see, like, it's really just like readable at this point. Like, you just copy and paste it. This is why I always like write my stuff out real quick and make it real logical. And it don't really take this long to write it out, but it was just me explaining stuff aloud. But when you really start practicing these, and y'all gonna learn the tricks real quick. But this really what my interviews be like. I write it like the chicken scratch, and then I just, it looked like you amazing coder. You see how I just code this shit real quick. Like they'd be like, oh shit, he dope. All right, so, but really what you did was take the time to break it all down before you even got to the computer. Make the difference for real, for real. All right, so now we want to check, looking at the iPad, we want to check if the target is less than nums. So, so that one don't go here. This one is find current number. All right. So we did check if the target is equal. This one is going to be check if the target is less than the current number. And so we'll say if target is less than. So usually they be having like the shortcuts. So writing all this shit out, low-key, making me practice my typing skills. And we'll do end equals midpoint minus 1. Dang, I know how well I had it on me. All them damn cheat codes. All right, check if the target is greater than the current number. So if target is greater than current number, bada boom, bada bang, begin equals midpoint plus 1. Let's check it if it worked. Oh wait, it's supposed to be elif. All right, y'all. It's about time we get to running this. All right. Oh wait, and then if it happens, we almost forgot. We need to, if it finishes, finished looking through the entire list and it and find comparison. So what we're gonna do is return -1. This is how you get a damn job. Like if you write your code out like this with the comments and shit, I swear to God, every fucking interviewer is gonna be like, check, we want him on the team. I swear to God, this is what happened with Microsoft. I did it like this, and it seemed tedious, but it honestly is really not even that damn tedious once you start doing it. It's really just you just saying the same thing over and over. And for me, it's just like I'm just restating my logic over and over so I can get it good. And so now what I'm about to do is just run it. And I'm about to run it against those test cases from earlier that we was running. So let me see like those examples. So learn that example right here. Test case. And we're going to bring this one. And the target was 9. Let's see if our binary search works. Remember, we're not looking at every value. So this should work. This is actually an algorithm. This ain't a brute force. This is we sat here and thought using logic, looking at the problems and all what we got. Like, let's make sure that it works. So here we go. And we didn't do it recursively. All right. Spelling words, begin. Y'all probably already seen that, huh? Let's see. Yep. All right, let's run it again. Scary, it's taking forever. Time exceeded. Oh shit. All right. So the time exceeded, meaning I had a run on somewhere. So while begin is less than in, let me try less than. All right, you probably shouldn't just try it out like that, but time exceeded still. Let me see. My bad. That damn grape juice was hitting. All right. Let's figure out why my binary search not working. All right. So basically what it's saying is it's running forever. And we're going to figure out why it's running forever. So got the midpoint in is N minus 1, 5, N minus beginning is 2. Let me print midpoint. That's how I do my debugging. Print statements. Let's see if they're gonna be able to get my print. You know what? I'll do a return. Okay. It's only staying 4. Interesting. Wait, if 4 is the answer. That makes sense. I didn't put equal. I put less than. Rookie mistake. But this is why we debug. Moving too fast. Run the code. Let's get an answer. Let's get a good one. Let's go. All right, bet. Let's see if it worked with that one with 5. Remember, that was a tricky hoe. All right. Run that hoe. Oh. Math was off. Let's see. Why was the math off? Let's see. We got one thing in the chamber. Begin and end are both 0. Less than, begin is less than end. This would have never ran. Less than or equal to. Let's run it. Man, I love being able to think logically. It's like a superpower. All right. But the thing is, now we got to go make sure that this one works too. That's how this coding shit works. When you change something, you got to go make sure it works on all of them real quick. Run that bitch. All right, bet. It worked. It's time to cash it in. Let's submit it. Let's see if we get it off the binary search. Got a success. And look at it. Runtime, 2 minutes or 208 milliseconds versus the other runtime was 339 milliseconds. We killed it. We saved over 100 milliseconds. This is, all right, well, a little binary search, it don't make too much of a difference right here. But I'm telling you, when you're doing stuff at Facebook, when you're doing stuff at Google, and you got all these people and whatnot, man, saving this a different amount of time is amazing. So we did dope. We did pretty dope today. All right, so I'm gonna stop the screen share. I'll try to stop the screen share. There we go. Yep. So appreciate y'all stopping by the live stream. It was fun for real. We're gonna get more and more professional, more and more structured. But I'm gonna find me another algorithm for next week, or 2 algorithms actually. I'm probably gonna start with some arrays or stuff. You'll get a quick little gist of Python as I teach each lesson, and then we're gonna jump into the algorithm and really sit and break them down and really get this like structure down. We're doing this every Monday and Wednesday. Come tap in. It's fun. It's good for me because I'm practicing my own algorithm, or these algorithms, get my mind back into it. Doing these puzzles is real fun for me. And so just it helped me put out more videos, and it helped the community. So you know anybody going through interviews and they just want an entertaining person to help them with some interviews, tell them come drop by every Monday, Wednesday from 9 to 10:30 EST. You can do the conversions at different time zones, but I'm gonna get with y'all on the next one. Also, wait a minute, every Sunday now, I actually think about Saturday or Sunday, you'll be seeing some flyers come out soon. Every Saturday or Sunday, I'm going to be giving out this course or this lesson. It's the first lesson in my main course that I got for $19.99, but it's this, I'm giving out the first lesson for free. And this is pretty much introducing anybody to technology. So if you want to get into technology, you never had any technical background, I'm giving out this free lesson every week. So if you miss it this week or next week, it's coming out every week. I'm gonna be giving it. People can ask questions. I'm gonna give it on my Discord so that y'all can ask live questions and I can answer them and whatnot. But it's really gonna give you a understanding of what coding is, what technology is, what computers are, and help you understand what the whole spectrum of it all means to you as a human and all the other stuff. All of this in one lesson, and it's gonna be amazing, y'all. So every Saturday or Sunday, y'all gonna be seeing the flyers come out. But tap in with me, share it with y'all peeps, and let them know we got some fun stuff coming out soon. So deuces. Figure out how to get out of here. I always say deuces. I should figure out how to dip first and then say deuces. All right, I figured it out. Deuces.